Okay, so I'm going to go over the first two units, just some basics. The first unit for chemistry is about conversions. That would be one thing, basic problem solving. So I'm going to unlock this. So looking at here, counting for significant figures. First, you watch a video on it, and then you work on the problems. When you put the correct info in, then it goes green. So the things to remember about significant figures are all non-zero numbers, like 1, 2, 3, 4, 5, 6, 7, 8. As long as it's not zero, it's significant. So where you have to be careful are the zeros. So non-zeros are sig figs. Okay. Then as far as the zero numbers, if they are sandwiched in between, then they are significant figures. So maybe you can think of the sandwich and significant figure. Help you remember the S in both. So that would be if they are leading zeros, then they are not. They are not significant figures. Like someone who puts himself first maybe is not significant if you want to put those two together or find another way to remember it. So the only zero we have here is sandwich, which makes that a significant figure. So therefore, there are 4 significant figures in that problem. Okay, looking at this one here, there's only one because the zeros are trailing. It's only one non-zero. There are no sandwiched zeros. There are no, the only significant figure is the 1, the 2, the digit 2, but 1 significant figures. Here they put trailing, leading zeros to see if you would recognize that those are not significant figures. Therefore, there are only 3 significant figures. Okay, now we're going to go to some other problems. So going back to my dashboard. Okay, looking at these problems here. So a student is experimenting with dissolving sugar in water. He can measure the volume of the water in the beaker, the number of spoons of sugar added, the time that it takes for the sugar to dissolve, and the temperature of the water in the beaker. So if he wants to investigate how the time taken okay, so again, if he wants to investigate how the time for the sugar to dissolve, so that's the dependent variable, the amount that you want to see how it's affected here, how the time for the sugar to dissolve is affected by the volume of water in the beaker. So the dependent variable depends on the water, on the volume of the water. So the volume of the water is the independent variable, the thing you're changing. And the dependent variable, you're saying, how does that depend on your independent variable? So when you're looking at a question or a problem, the independent variable is the quantity that you're changing. The dependent variable is the thing you're measuring the change of when you change the independent variable. Control variables are the things that are staying the same. Like you're not changing the water temperature, not changing the spoons of sugar. So you can see if you put the wrong item in and then change it, it turns this color green. This color green means you put it in right from the start here. Whoop. Okay. Let's look at another one. Okay, a student is experimenting with a pendulum. She can measure the length of the string, the angle of release, the mass of the pendulum bob, and the time the period taken for one full swing back and forth. So she wants to see how the angle of release affects the time period. So the dependent variable would be the time period, and what she is controlling is the angle of release. So she changes the angle of release to see, okay, how does that affect the time period? So the time period is depending upon her angle of release. And the two variables that she controls and doesn't change. So it says she can measure the angle of release she's changing and the time period she is evaluating. So the mass of the pendulum bob is staying the same. So the angle of release, those are independent, dependent variables. So the control one must be the mass of the pendulum bob and the length of the string. So that's this one here. And then we check it. And those are correct. Okay. Let's okay, let's do one more. All right, a student is experimenting with releasing a ball from the top of the ramp. She can measure the height of the ramp, the time taken for the ball to reach the end, the mass of the ball, and the roughness of the material. So what exactly is she wanting to measure, to control and see how that affects something else? So what she wants to find out is how the time to reach the end is affected by the height of the ramp. So she's going to be changing the height of the ramp, That's what she's changing. And she wants to see how the time taken, it depends on the height of the ramp. So that's how you get those. And the two that are left over would be the other two variables. So height of the ramp we're messing with, and time taken, we're seeing how that's affected. So we're going to keep the mass the same, and there she is, and the roughness the same. So I'm looking at that one. Okay, so now we'll go on to the next part. Okay. Next part is, let's see, we did counting significant figures. We did experimental values. Now we're going to do rounding. So for rounding, it says round to the nearest whole number. So the whole number would be 1. So you look to the right, and if it's 5 or above, then you're going to round that number here, 1. You're going to round it up, and it is above 5. Therefore, it's 702. Okay, let's look here. Round to 3 significant figures. So we have to know 2 things. What are significant figures? Remember that the leading 0 is not significant. So that puts us at 885. We look to the right, that's a 9. So that kicks the 5 up and makes it 886. So that's dot decimal point 886. And that's correct. So let's do one more. Let's do number 8. Round to 3 significant figures again. Remember, all non-zero numbers are significant figures, right? So those are non-zero numbers. So you look to the one right beside it, which is a 4. That's less than 5. Therefore, we're going to leave it at 74.7. So that's 74.7. And that's correct. Now we'll go back to the next thing, which is scientific notification. Scientific. So let's look at this one. I already did. So scientific notation, sorry, I think I said notification. Scientific notation is where so when you're doing these science experiments or when researchers are doing it, they can have really big numbers or really small numbers, and scientific notation allows them to write the number in a way that's not so has so many digits. And so here you want to have one significant digit past the decimal point. Okay, so here it's 4. And then you want to use times 10 to whatever power. If it's a -3, that times 10 is just telling you which way to move the decimal point and how far. So negative means to the left. You could think of just like on a number line, right? The negative numbers are to the left, right? Like -1, -2. And positive numbers are to the right. So if it has a -3, we're going to move it to the left. 1, 2, 3. Well, what do you put here? Well, there were no significant digits given, so we just put zeros. So that's how I got that number there. I moved the decimal point over 3 times. Okay. Now we're going to look at this one. This is going -6. So remember, we move it to the left. So we put the scientific notation 1 significant digit to the left, and then we use this part to say what the number actually is. So if it's -6, that's 1 to the left, 2 to the left, 3 to the left, 4 to the left, 5 to the left, 6 to the left. So that's 0, 0, 0, 0, 0, 5 zeros, which is what that is right there. 1, 2, 3, 4, 5. And then the 8. Okay, let's move on to the next. And I don't think I'm going to be doing the density chapter along with this. In fact, think I'm gonna stop here to keep my videos smaller so that this video covers the counting significant figures, experimental variables, rounding, and scientific notation. Let me look and see if there isn't another problem I'd like to do. Okay, here's another variation of problem. So before we were going from scientific notation to expanding it, right? And now it's putting it into scientific notation. So you want to take that decimal point and move it so it's it has one digit to the left of the decimal point that is significant. So you count how far would you have to move that over in between each zero. That's 1, 2, 3, 4, 5, 6, 7. So it took 7 hops to get it over there where there's one significant figure to the left of the decimal point. Therefore, that was 7 hops, and it's going to be we need it to go to the left, right? Because that's not correct, because that is where because that is where we want the decimal. It's like if we're putting it in scientific notation, we're telling somebody which direction to move the decimal point and how far. So remember when we were looking at it before, if it was negative, we'd go to the left. And that's what we would want somebody to do to get from this notation, this way of stating the number to this number. The person would need to go to the left 7 points. So let's check that. And that's correct. Okay, so I'm going to turn off the recording, and then I'm going to, from there, make some other videos so you don't have so much to watch at one time.